Oh, today we're going to pull the parameters out of a blown up KEB drive. Oh, it destroyed itself, but luckily the CPU board survived. And its article number, right here's the cover, it's article number 10.F4.F1D-3440. Let me show you the part that blowed up. Hold on, I'll be back in just a sec. Now, I've cleaned it up a little bit, but you can see right down in here the W leg, the two IGBTs for the W leg, they're under this power board. They exploded and they shot back up into the feedback board and shorted the plus and minus 15 volt regulators and the ICs attached to those regulators. It is a mess. It took a little while, took a little effort to get that feedback board straightened out, but I did. And luckily we had bad parts in the North 40 where we keep all our broke stuff. We hold those back for parts, and they do come in handy, so don't throw nothing away. What we're going to do, let me get over here to the bench and I'll show you what we're going to do. We're going to tack wires onto the CPU board and we're going to connect that board to the laptop and use the CombiViz program to download those parameters. So give me a little bit to move the camera and we'll get over there. And when I get back to the house, I'll show you how to power up a control board, a KEB control board, CPU board from external power supplies so you can pull your parameters out. Now here is the CPU board. I got it powered up and this red LED is blinking. But there's a regulator over here. We're only worried about powering up the board and powering up this little connector right here. This connector is where the panel connects to. And we have a panel, we have a KEB panel that has an RS-232 port on it that we're going to connect that RS-232 to the DB9 connector in the back of this laptop here. So I've got 10 volts tacked onto this little regulator. There's two 5-volt regulators right here. One to power up the control and another one in a TO92 package that powers up the panel. I got this power supply right here, 10 volts to power up those two 5-volt regulators. Now over here I've got plus and minus 15 volts. And the grounds of both power supplies are tied together. And the plus and minus 15 is for the RS-232. If you don't have that on there, you can't have the plus and minus voltages of the RS-232 standard. So without this power supply, it won't communicate. Okay, now let me show you the panel that we're going to use to connect that CPU board, that control board, to the laptop. This connector right here plugs into this connector just like that, and the DB9 connector is the RS-232 port. So let me power down and get this all connected up. Other end of the RS-232 cable connected to the DB9 connector, the COM port in the laptop. And we connect that right there. So put this down on here. Don't bend no pins over, people. Okay, I'll try not to. Let's power up. Okay, we have an alarm E.HYB. That's the feedback board. We don't have the feedback board connected to the CPU board. That's why we get that alarm right there. If we had the feedback board connected to that board, we wouldn't have that alarm. It would come up to the frequency 0.0. Now with all this connected, let's get close to the laptop over there and I'll open up that CombiViz program and we'll start to download the parameters. Alright, I'm going to double click the CombiViz icon. And right now it's hunting for that CPU board. When it finds it, the program will automatically open up. There we go. It found it. Now let's back up, if I can. Not jiggling the panel too awfully bad. What we want to do now, go over to File, go to Parameter Saving, click on that. And our CPU board is at address 2, they call it node 2. Click on OK. And it says up/download in progress, and you have a progress bar right there. We're not uploading, we're downloading. I don't know why they can't differentiate between the two. That's kind of scary. I wouldn't want to be putting bogus parameters into the parameter set that's inside that CPU board. But anyways, there we go. Up/download finished. Click on OK. Now we're going to give it a name. Now let's call it Job ID 5516. Click on Save. There we go. We just saved the parameters from that blown up drive. Alright, there we go. When I get to the house, I'll show you how to hook this thing up. So you can download your parameters from a blown up KEB drive. As long as the CPU board is operational, you can pull those parameters without having it sit on the main power supply. Afternoon all, we're at the house. Now down here is the 78LR05 that powers up the logic. We have a voltage and ground comes in here, and that voltage and ground are regulated down to 5 volts for the logic to power up the CPU board. Up here we have the operator panel with the RS-232 port so that we can communicate to the laptop. That panel is powered up from a 78L05. Now in some instances you'll see a L4940V5. Not a problem. This right here is the TO220 package, but in our case we had the TO92 package, which was the 78L05. Now, their input, voltage in and ground, are derived from a switch mode power supply on the feedback board. Now, I had the feedback board disconnected, and I applied 10 volts and ground to the VN of both these devices. That is where the yellow wire was connected and the green wire connected. I had the green wire connected on the tab of the 78LR05. I had the yellow wire connected to pin 1 of the 78LR05, and that powered up both these devices right here, the CPU board and the panel with the RS-232 port. Now let's go look at how to power up the RS-232 plus and minus. Now this is the same connector, CN303, that the operator panel and the DB9 RS-232 port are attached to on the control board. Now on pins 16 and 18, I had the white wire soldered to those pins right there. The white wire being 15 volts plus 15 volts DC. On pins 13 and 15, I had the blue wire and applied a minus 15 volts DC right there. This is a 26 pin connector right here, CN303 label on the CPU board. Let me show you the locations of those two regulators in relation to this CN303 connector. Now I'll show you 6 pins of the CN303 connector right here that panel plugs into. Here's pin 1. We're looking into the pins. Pin 1, pin 2, pin 3, pin 4, pin 5, pin 6, 7, 8, 9, 10, all the way out to pin 26. Right here beside that connector is a capacitor. This is a filter capacitor. This right here is the 78 LR05. It has 1, 2, 3, 4, 5 pins plus tab. This middle pin right here and this tab are ground. This pin right here, pin 1, is V in, and pin 5 up here is V out. And right above it is the 78 LO5. That's a 3-terminal regulator in the TO92 package. There you go. Now in a little bit, I'll put some pictures up and we'll look at all of this where we soldered the wires onto so you can have this paper representation and a visual representation of where to solder your wires onto. Okay, give us a little bit to get there. We're almost done. This voltage regulator right here is the 78 LR05, and I'm applying 10 volts to pin 1 and ground to the tab. Pin 1 has the yellow wire attached to it, and the tab, ground, has the green wire. This right here is V in and ground. The output on pin 5 powers up the CPU board. Now over here is the 78 L05, and its input powers up the panel with the RS-232 port attached to it. This here is the back side of the CN303 connector, and this is the same connector that the panel connects to with the RS-232 port. Over here is pin 1, pin 2, pin 3, pin 4, pin 5, 6, 7, 8, 9, 10, 11, 12, 13. Now 13 and 15, there's 15 right there. 13 and 15 are where the negative 15 volts DC is applied. And I'm applying that on this blue wire right here. Let's count back. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and 18. There's 17 and 18, 16, 17, and 18. On the white wire is where I am applying plus 15 volts DC. Now, if you don't have these two connected, even though you have 10 volts to power up the control and the panel, if you don't have these two, plus or minus 15, plus 15 on the white wire, minus 15 on the blue wire to power up these 2 points right here, you will not have RS-232 communications. You have to have that plus or minus 15 connected to that panel that has the RS-232 DB9 connector COM port. Well, there you go. That's everything we need to know to power up this CPU board from that KEB drive to successfully communicate to the CombiViz program, CombiViz 5, on that laptop. Alright folks, hope this helps you out and saves you a little bit of time in trying to reverse engineer your KEB drive. We'll see y'all in the morning when the sun comes up. Now, when I first started trying to communicate between the KEB HMI panel that has the RS-232 port and the laptop, I couldn't get it to work. I had 2 to 2, 3 to 3, 5 to 5, and nobody wanted it to communicate. And then what I did was I took this panel right here apart, that KEB HMI panel with the RS-232 port, and I found out that pin 7 on the DB9M connector was ground and not pin 5. Well, the standard, if you ever look it up, the RS-232 standard says that 5 is ground, but over here, pin 7 on that KEB HMI panel with the RS-232 port was ground. So what I did was I made an adapter cable that would take the PC COM port DB9F to 2, 2 to 2, and then 3 to 3, and 5 to 7 on the drive instead of 5 to 5. When I went 5 to 7, we had good communications on the transmit and receive. There you go. So if you ever cannot communicate from your laptop to that drive, make you an adapter cable that looks just like this. Here, ground on the PC side, pin 5, and ground here on the drive side, pin 7. Now normally, pin 7 is associated, pin 7 ground on RS-232 standard is associated with the DB25 connector, not the DB9 connector. Well, ain't that amazing? Ain't that amazing how I got to go through all that kind of trouble to get to make two devices talk together? I would not have to do that. If the one side had been the normal standard, we wouldn't have had to do that. Alright folks, y'all have a good night. We'll see you next time.